Hi class, how are you today? That's radiant. The learning target for today is to be able to convert an angle measure of any type to an angle measure between 0 and 360 degrees and between 0 and 2 pi radians. The scale, for 3, you can do what I just said, convert an angle measure of any type to an angle measure between 0 to 360 degrees and between 0 and 2 pi radians. 2, you can convert degrees to radians and vice versa. 1, you can find coterminal angles if it is in degrees. And 0, you cannot find coterminal angles. Let's get started. First, let's talk about radians. What is a radian? A radian is a unit of angle equal to an angle at the center of a circle whose arc is equal in length to the radius. Well, what does that mean? It means, let's say we have a radius with length 5. That means 1 radian will allow us to have an arc length of 5. And this isn't in degrees, it's in arc length. We'll be talking about arc length in the next lesson. But the actual distance from each intercepted arc is 5. Converting with degrees and radians. So the way you convert degrees to radians and radians to degrees is with proportions. So, with degrees and radians, 180 degrees is equal to pi radians. Those are the same thing. So if you have 180 degrees, then you have pi radians. So if we want to turn any degrees into radians or radians into degrees, all we have to do is set up a proportion with 180 and pi as denominators, so we're comparing them to each other because they're equal. So let's start with number 1. We've got 30 degrees and we want to convert it to radians. So we set up the proportion. 30 over 180 is equal to r over pi. Now you can reduce that fraction first if you want. You don't have to, because then we can just cross multiply. 180r is equal to pi times 30, or 30 pi. And we want to solve for r, so we divide both sides by 180. And that will give us r equals 30 pi over 180, but we can reduce that. 30 over 180 can reduce to 3 over 18, which can reduce to 1 over 6. So it's the same thing as saying pi over 6. So 30 degrees is pi over 6 radians. Another way you can think of it is pi is 180 degrees, and 180 degrees divided by 6 is 30 degrees. So that's what we're doing. We're just taking pi, which is 180 degrees, and dividing it by 6. So just think of 30 degrees as 1/6 of 180, or 180 divided by 6. Number 2, we have 160 degrees. So, same thing, 160 over 180 is equal to r over pi. Cross multiply, 180r equals 160 pi. Divide both sides by 180. And that will give us r equals, and 160 divided by 180 can reduce to 16 over 18, which can reduce to 8 over 9. So we've got 8 pi over 9, which is the same thing as saying 8 times 180 divided by 9 will give us 160. Now let's convert radians to degrees. So this time we've got d over 180 is equal to pi over 2 over pi. And now we just cross multiply. So that will give us d pi is equal to 180 pi over 2. So 180 pi over 2 is the same thing as saying 90 pi. So now we divide both sides by pi. And that leaves us with d equals, and the pi's can cancel to leave just 90. So pi over 2 is the same as 90 degrees. You can also see that because 180 divided by 2 is 90. So you didn't have to set up the proportion that way, but it allows you to see it. So whichever strategy you use is up to you. So here we've got 7 pi over 6. So we've got d over 180 is equal to 7 pi over 6 over pi. Same thing. d pi is equal to, now I find it easiest to take 180, divide by the denominator of the fraction here. So 180 divided by 6 is 30, and then multiply by the numerator. So 180 divided by 6 is 30, times 7 is 210. So 210 pi, and then of course divide by pi, and that just again gets rid of the pi's, and we're left with d equals 210. So 7 pi over 6 is 210 degrees, but again, 7 times 180 divided by 6, also 210 degrees. Coterminal angles. Those are angles that share the same initial side and terminal side. So what I mean by that is initial side, we usually start at 0 degrees. So we've got a coordinate plane here, but we're just going to be using it for degrees. So the terminal side is where it ends. So if I say I want 45 degrees over here, so I want to draw 45 degrees. So 45 degrees would be about halfway. So I'd draw an arc that would go up to 45 degrees. So that is a 45-degree angle. Now, what if I said 405 degrees? Well, that's an issue because we've only got up to 360. We start at 0, and if we went all the way around, we'd hit 360. What do we do then? Well, you keep going. So, 405 degrees would be going around once, and then you'd be going some more. So let's see how much that is. So going around once is 360 degrees, and we have our 405. So if we run around once, we'd have to go another 45 degrees. So we go around once, and the second time we end at the same spot. So 45 and 405 are known as coterminal angles. So 405 and 45 effectively have the same degree measure. It's both the same amount of degrees, however, one just goes all the way around first and then ends at 45 degrees. And then let's look at negative 315. So, same thing. We can't go in the negative, can we? Or can we? Going in the negative would start at the same spot and go backwards. So, we go backwards 315 degrees. So if we were to go backwards 350 degrees, we would go around and end at, 45 degrees. And you can calculate that by saying 360 minus the 315, because 360 is a full time around, and that'll give you 45. So these three angles here are all coterminal. They end at the same spot. So what I want you to learn from this is how to figure out what the angle is between 0 and 360. If I give you an angle, what is the angle if it was between 0 and 360? Now let's do the same thing with radians. So, 2 pi over 3 radians. For those of you that want it in degrees first, that's perfectly fine. 2 times 180 is 360. 360 divided by 3 is 120. So that's the same thing as saying 120 degrees. So, we go around, and we end at 120, or 2 pi over 3 radians. Now, what if I have 8 pi over 3 radians? Well, we've got 2 pi radians is full amount away, so what we need to do is we need to keep going after that. So the same thing we did with degrees, we've got 2 pi minus so we need to take the 8 pi over 3 and minus 2 pi. Well, first we'd have to turn it into a fraction, 2 pi over 1. So 8 pi over 3 minus 2 pi over 1. So it becomes 8 pi over 3, and then you need to make 2 pi over 1 into something over 3, so you multiply the top and the bottom by 3. That'll give you 6 pi over 3, which will give you 2 pi over 3. So 8 pi over 3 is the same as 2 pi over 3. It just goes an extra length. So it goes around once and comes back again and ends at 2 pi over 3. And then with negative 4 pi over 3, so we just do 2 pi minus 4 pi over 3. So that's the same thing as saying 2 pi over 1. Multiply the top and the bottom by 3. Again, 6 pi over 3 minus 4 pi over 3 gives us 2 pi over 3. So this one also ends at 2 pi over 3, but it goes backwards. So this one starts here and goes backwards here. And all of these are coterminal angles. These last three 2 pi over 3, 8 pi over 3, and negative 4 pi over 3 are also all coterminal angles because they all end at the same side. Alright, now time for the sponge. For the first three, I want you to convert each degree measure to radians between 0 and 2 pi. So convert each of these degrees to radians, 120 degrees, 570 degrees, and negative 60 degrees. Convert them to radians, and then change them so they're between 0 and 2 pi, like we just did. And then the last three, convert each radian measure to degrees between 0 and 360. So 5 pi over 6, 7 pi over 3, and negative 11 pi over 6. Convert those to degrees, and then, like we just did, change them so they find the coterminal angle between 0 and 360. That's it for the lesson. Once again, please make sure to take notes on the entire lesson. Go back to the beginning, rank yourself, take a picture of everything, submit it all to Google Classroom, and have a good night.